This is an example using the contradictory premises rule and conditionalization. The theorem to be proved is the same as on the conditional disjunction example video. As on that video, the example is presented symbolically only, without a story. Feel free to devise your own story to fit it. The premises that we will be considering for this problem are Q or P, together with not P, and the negation of the conjunction of Q and S. The conclusion we seek is S implies R. How should we construct a proof of this? As we often do, we will try to argue backwards from the conclusion. The conclusion is S implies R. We look at the premises and see no mention of R. If you like, R has appeared from thin air. We have only two rules that allow us to introduce statements from thin air. One is the addition rule, and the other is contradictory premises. This particular proof is going to employ the contradictory premises rule. However, as has been said, an alternative proof of the same theorem using addition is found in a separate video. This proof will also use conditionalization. The conclusion is S implies R. Conditionalization allows us to assume S as if it were an extra premise. If we were then able to conclude R from S together with the original premises, then the conditionalization rule says we can conclude S implies R without the premise S. Again, however, R is not mentioned any place in the premises. To reach a conclusion R, if the addition rule is not to be used, we must use the contradictory premises rule. That says we must find some contradiction among the premises. The premises that we will be allowed to use are the three premises that are given together with the conditional premise S. From the first two premises, we see that since at least one of Q or P must be true and P must be false, then Q must be true. If we are assuming the conditional premise S also, then Q and S must be true. However, the third premise says Q and S is false. Those will be our contradictory premises, and from them we will be able to conclude anything we want. In particular, we will be able to conclude R. This is the basis for our proof. If you would like to produce the proof on your own, you should pause this video now. Here then is the proof. We first list our three given premises, Q or P, not P, and the negation of Q and S. From the first two premises and the disjunctive syllogism rule, we conclude Q, since at least one of Q and P must be true, yet P is false. Now let's introduce the conditional premise S on line 5. Doing a conjunction of lines 4 and 5, we have Q and S. Now comparing lines 3 and 6, we see that they are the negations of one another. So we do have contradictory premises. Therefore, we are able to conclude anything we want. What we want to conclude is R, so line 7 has the statement R from contradictory premises applied to lines 3 and 6. Let's remember, we have not proved R from the original premises. The only way we obtained R was the introduction of the conditional premise S. The conditionalization rule allows us to say that from the original premises we have S implies R. This is called discharging the conditional premise. We remove it from the set of premises and use it as the antecedent in an implication. Line 8 shows the discharge of the conditional premise S and the use of S as the antecedent in the implication S implies R. We say, using conditionalization discharge from lines 5 and 7, we have S implies R. This concludes the proof.